All right, so I wanted to do a couple optimization examples here, and optimization problems really start to all feel the same after a little bit. You are setting up a situation, you're writing your equation, you're taking a derivative, setting it equal to zero, and trying to interpret what that means. Obviously, they can get tricky sometimes, so you want to draw a picture and just make sure that you're being very careful with what each of the pieces are. So I'll do sort of the classic one where you're building a field here, and one side of it you don't need to build the fence on, and you want to have your area be 200 square meters. So let's call this the width and the length. And so what I know is that the area of my field is going to be width times length, and that's going to equal 200. What I want to try to do is minimize the fencing, and so I want to minimize the perimeter equation where I've got 2W plus L, because the other L on the left side of my picture is taken care of. If I rearrange my area equation, I get that L is 200 divided by W and substitute that in there. 2W plus 200 over W. Get used to, when you're doing derivatives and integrals, writing it as a negative exponent. Then you take your derivative, 2 plus, I guess I should have written minus 2 plus negative 200 w to the negative 2, and set your derivative equal to 0 to try to find your critical points. I'm adding 200w to the negative 2. I'm going to multiply by w squared, divide by 2, and take the square root. Think about only one of those values makes sense. We're not going to have a negative width, so I really am only going to look at positive 10. If I take the second derivative of my perimeter, I can see that my second derivative is positive 400 w to the negative 3. And this is greater than 0 for all w that are greater than 0. What that means is that I have a concave up perimeter function. So the critical point that I found has to be a minimum. And what am I trying to find? I'm trying to find the least possible length of fencing here. And the word length in the problem statement means like all of it together. It means the whole perimeter. Even though I used the letter L earlier for the length of the rectangle, I need to find the entire thing. And so if my W is 10, then I can go back up here to my L equation, and my L is going to be 200 divided by 10. So my L is 20. My total fencing that I'm going to need to buy is 2 times W plus L, ends up being 40 meters of fencing. So that's a pretty classic optimization problem. I'll do a couple more examples just so you can see some ways that it can be a little different than that. So comment, like, let me know if there's anything else I can do to